Hello students, let us continue the session on playing with the numbers. In the previous session, we had solved exercise 3.4 question 1 and question 2. We shall continue the exercise question number 3 onwards. Let's begin. Question 3 is related to multiples. We need to find first three common multiples of first one 6 and 8. As we were doing for the factors, we will follow the same method. First we will write down the multiples of 6. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42 and so on. Let me write some more so that we will be getting more numbers. 48, 54, 60, 72 and so on. The multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72 and so on. Now the common multiples. We have been asked only the first three common multiples. So first one here, I'll change the color so that you will be able to identify. The first one is 24. Second one is 48. And the third one is 72. So the common multiples are 24, 48 and 72. Let us do the second one in the same manner. Second one, we need to find the multiples of 12 and 18. So first let me write the multiples of 12. The multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96, 108, 120 and so on. It continues. Multiples of 18 are 18, 36, 54, 72, 90, 108 and it continues. Now I need to write the common multiples. I'll write the first three common multiples of 12 and 18. First let us identify. Here we have 36, the first common multiple. The next common multiple is 72 and the third common multiple is 108. So the first common multiples are 36, 72 and 108. Let us look at the question 4. Write all the numbers less than 100 which are common multiples of 3 and 4. The number should be less than 100 and they should be common multiples of 3 and 4. What we can do is, we will first find out the common, before finding the common multiple, let's find out the multiples of 3 less than 100. So it is little lengthy. Let me write it here, multiples of 3. This part I'll write multiples of 3. They are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69. Then we have 72, 75, 78, 81, 84, 87, 90, 90, 93, 96, 99. These are the numbers which are the multiples of 3 which are less than 100. Same way, let me find out the multiples of 4 which are less than 100. They are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, and the number 100 is also divisible by 4. However, they are as less than 100. Let me not consider this. Now we need to identify the common multiples. Common multiples of 3 and 4. They are, I will highlight the common multiples. Here we have 12, the first common multiple. The next common multiple in line is 24. The next common multiple will be 36. Next to that will be 48. Next is 60. Next one is 72. Next to that is 84. And the last common multiple less than 100 is 96. So let us write the common multiples. 12, 24, 36, 48, 60, 72, 84, and 96. These are the common multiples of 3 and 4 less than 100. Question number 5. Which of the following numbers are CoPrime? I'll give a little brief on the meaning of CoPrime. CoPrime refers to the prime numbers. There are, say, let 2 prime numbers are there. They are said to be CoPrime if 2 primes are having only one common factor, or common factor must be equal to 1. If the common factor of 2 prime numbers are equal to 1, then we say that they are CoPrime. With this, I will also give the meaning of twin prime. Twin prime refers to 2 prime numbers. They are also 2 prime numbers such that their difference is equal to 2. Say for example, 3 and 5, they are twin prime, because 5 minus 3 is 2. Not only 3 and 5 twin prime, they are also coprime, because the highest common factor for 3 and 5 is only 1. So you must have understood now the meaning of coprime and twin prime. Now in this question, we are asked to find out whether this pair is a coprime or not. For that, I will write down the factors of 18 and also the factors of 35. Let us write the factors of 18. It is divisible by 1, 2, 3, 6, 9 and 18. The factors of 35 are 1, 5, 7 and 35. Look at these two factors. Identify the common factors. I'll write in short, CF refers to common factor. Here the common factor is only 1. Since it is having only 1 as a common factor, we say that the given numbers are coprime. Here I'll write, since both have only common factor which is equal to 1, 18 and 35 are coprime. I'll take up one more question and I'll tell how to check whether the given pair as a coprime or not. This time I will consider the third one, 30 and 415. So see, I will first mention the factors of 30. Then I will mention the factors of 415. What are the factors of 30? 30 is divisible by 1, 2, 3. It is divisible by 5 also, 6 also, 15 as well as 30. The factors of 415 is 1, it is divisible by 5 and so on. I need not write all because I got the information that the common factor is not just 1, it is also having 5. So when more than one common factor is there, then I can say that the given pair of numbers are not coprime. Since both have more than one common factor, this implies 30 and 415 are not coprime. Understood? Rest of the questions B, D, E, F, I want you to solve. Question number 6. A number is divisible by both 5 and 12. By which other number will that number be always divisible? A number is divisible by both 5 and 12, which means if I consider 5 multiplied to 5 multiplied to 12, is 5 multiplied to 12, the product becomes 60. So this number 60 is divisible by both 5 as well as 12. By which other number will that number be divisible? Always it will be the number itself. The number must be divisible by 60. So for example, in some other question, if they give a number is divisible by both 3 and 7, which other number will divide that number? Which means I need to multiply them. I'll be getting 21. This 21 is divisible by both 3 as well as 7, and this number is also divisible by 21. Understood? Let's see the next question. This question is the last question for the exercise 3.4. Question is, a number is divisible by 12. By what other numbers will that number be divisible by? To find by what numbers, other numbers, I need to find out the factors of 12. The factors of 12 are 1, 2, 3, 4, 6 and 12. Which means the number also be divisible by 1, 2, 3, 4 and 6. I'll give one more example for that. Suppose if a number is divisible by 8, say I'll take, say 32 is divisible by 8. The factors of 8 are 1, 2, 4 and 8. All these numbers will divide 32. We get 1 multiplied to 32 as 32, so 32 is divisible by 1. 2 multiplied to 16 as 32, so 2 divides 16. 4 multiplied to 8 gives 32, so 4 as well as 8 divides 32. It is like that. If a number divides another number, their factors also will divide that number. With this, we have completed exercise 3.4. We shall look at exercise 3.5. The first question of exercise 3.5 is to state whether the following statements are true. If a number is divisible by 3, it must be divisible by 3. This is a false statement. Why? 6 is divisible by 3, but 6 is not divisible by 9. We will not get a quotient as integer. So this statement is a false statement. If a number is divisible by 9, it must be divisible by 3. This is true statement. Whenever the sum of the digits is divisible by 9, the same rule is applicable for divisibility for 3. If a number is divisible by 9, it must be divisible by 3. Third one, a number is divisible by 18 if it is divisible by both 3 and 6. This statement is also true. 18 is multiple of 3 and 6. 3 multiplied to 6 gives 18. Whenever a number, say 36, is divisible by 18, this 36 is also divisible by 3 and 6. So this statement is true statement. If a number is divisible by 9 and 10 both, then it must be divisible by 90. It is true because we have understood an example in exercise 3.5. A similar type of question was there. If two different numbers are there, if a number is divisible by both these numbers, then the product also will divide that number. Next statement E. If two numbers are coprime, at least one of them must be prime. So this is a false statement. It's not necessary both can be prime. All numbers which are divisible by 4 must also be divisible by 8. This is again a false statement. 4 is divisible by 4. It doesn't get divided by 8. So it's a false statement. Next statement. All numbers which are divisible by 8 must also be divisible by 4. This is a true statement. If a number exactly divides two numbers separately, it must exactly divide their sum. This is also a true statement. If a number exactly divides two numbers, say for example 3 divides 6 and 9, 3 also divides 6 plus 9. 3 divides 6 and 9. 3 also divides their sum 6 plus 9, which is 15. This statement is true for all the numbers, right? Next statement. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. This is a false statement. If a number divides the sum of the numbers, it must divide two numbers separately. Suppose if I consider 3 dividing 15, which is the sum of 13 and 2, 3 need not divide 13, 3 need not divide 2. It doesn't divide actually. 13 is not divisible by 3, 2 is also not divisible by 3. This statement is false. We shall solve one more question for today's session. Question number 2. Here, two different factor trees for 60 are mentioned. We need to find the missing numbers. 60 is 6 multiplied to 10. I'll change the color. 6 times 10 gives 60. Here 2 multiplied to which number gives 6? It must be 3. So this missing number is 3. 5 multiplied to which number will give 10? It must be 2. So this missing number is 2. In the next one, 60 is the product of 30 with one more number here. It has to be 2. 10 multiplied to which number gives 30? It has to be 3. 10 is a product of two prime numbers. Which are they? 5 and 2, because 5 times 2 is 10. With this, I'll end today's session. We shall discuss the remaining questions in the next session. Thank you.